Okay, so this is a video where I'm going to be going through the slides for the access chapters, chapters 1, 2, and 3. So, um, the basic concepts, we talk about what a database is. A database is a collection, organized collection of data, characterized by a definition of rules defining what things will look like, what the database should look like. It's different than a spreadsheet in that where spreadsheets are basically designed to be flexible and you can basically do whatever you would like with it. Databases, there's a lot more discipline, a lot more structure. All right. So the reason why we have databases, the purpose they serve, is it's the platform where we store data. So what will happen is um, all these different activities. You think about what's going on in an organization, millions of different events that are being generated by business processes. There's a need to store that information, capture that information, store the information in some sort of accessible way. So that's what the purpose of a database. Um, database provides a way to capture, process, and store data. So at the core of every application, almost every application, like an ERP system, there is a relational database that sits at the core. So a real brief history. So originally databases have been around actually since the 60s. The original database systems were developed for mainframe systems. IBM had a platform called IMS back in the 60s. So uh, it predates. So that what we're talking about here, the modern or the modern platform for databases is what we call a relational database. So they've been the mainstream architectural model for most systems since the 80s. It was developed by a gentleman by the name of E.F. Codd, Edgar Codd, who was actually working for IBM at the time, who published a paper in 1970 describing a database based upon relational algebra. So the idea of relational algebra deals with set theory of what basically what's the union of two sets, what's the intersection of two sets. So uh, Codd's theory, basically his theories, because actually he wrote one paper, but he also did ongoing research um, all through the 70s into the 80s and through the 80s, dealing in this field. He basically developed this model, the idea of being able to store data uh, and more importantly, be able to query the data, being able to get the data out of the system, be able to put data in, but also being able to get data out of the system. So, so this has actually been the foundation of databases as modern databases as we work with them. And we'll see this as we go through. There's a couple key concepts, come to the terminologies we're looking with this. So we got databases, which is a organized collection of data. A relational database, which is a organized collection of data that's in what we call the relational form, basically in the form of tables. All right, so the characteristic of a relational database is all of the data is stored in some form of table, and then the tables can be connected together and organized together based upon the relations between them. Hence the name. The hierarchy, if you look at the different components, all right, you start off with the field of data, basically, which is the data. There's a couple different terms we use. We use the term field. We use the term column. We'll use the term attribute. They're all basically mean the same thing. It's an individual unit of data. All right. A collection of fields makes up what we call a record. All right. So it's which is a series of related fields pertaining to a particular entity or an event. A table is a collection of records. So you can have, we'll say, for example, we'll use an example of an order date. You're going to order something on Amazon, so you have a date it was ordered. So that's going to be the field. All of the other information about your order is collected together and stored in a record. Right? All of those records of everybody who's done orders in Amazon, you know, for whatever time period, those are in the table. and then finally, the tables are, a database is a collection of table. The other key concept to remember is that there's a difference between a database and a database management system. So the database is actually a structure, a file structure, where how data is stored, whereas a database management system is software that's specifically designed to manage the database, and also to serve as the interface between a user and the data. So the DBMS, what you'll is really the software part. Is the thing you see when you're working with it. The database itself is actually a collection of data. So some definitions: database, very large integrated collection of data. Models a real world enterprise. So a database, if you look at all the tables in the database, it's really um, defines, it's model what it does. It will model an event or a process. So we'll take, for example, an order. All right, so an order database. An order database will have the structure of an order will be a collection of all the different fields that are related to that order. All right, and then you know, as we call it here, structure collection of data, of like data, that forms information. So um, we're actually, what you can do is it's a storage of data which then can be used to derive information. And this idea of relationships. So relationships will connect these different collections of data so you can retrieve it. So as we just kind of a repeat here, database is one of many tables. Tables made up of many fields. Fields are broken into individual records. All right, a table can have one or many records. Relational databases we had talked about. So this is what we call an ERD, entity relationship diagram, which really gives you a picture of what a database, the structure of the table. So these items, these objects right here, are the tables, the table definition. So we'll see a field name. All right. So we'll see, and we also see the key. We'll talk about that in a minute. So departments, classes. This is with so this would model a school and the classes and the instructors, and the relationship between the different tables. So, for example, you can have a one-to-many relationship. All right. So for every one department, there are many classes. All right. However, for every class, there is only one department. And the same thing is here. An instructor can teach many classes, all right, but a class can only have one instructor. All right, so, and this is a tool by which you can, the ERD is something you would, usually if you're working with this stuff, you would use to really identify what's going on, kind of where data is at, and kind of how things are aligned. As we say, relational database, collection of tables are related to one another based on a common field. So DBMS is software, as we said, designed to store and manage databases through which users interact with databases. Popular ones, some well-known ones. Oracle is probably the biggest. Microsoft also has one called SQL Server. IBM has something it calls DB2. So those are all enterprise scale relational databases, or DBMSs, database management systems. We're going to be working with Microsoft Access, all right, which is a part of Microsoft Office. From a technical perspective, if you look at the way, kind of following relational models, Access is the same thing as Oracle, in effect. All right, they use the same principles. However, the actual scalability, how it's utilized, Oracle is a industrial scale application capable of supporting thousands upon thousands upon thousands of users, whereas Access is really meant to be a desktop system. MySQL, so this is all, for the most part, this is all licensed software. However, there are open source platforms like MySQL is an open source platform. All right. And what we're going to be working with, Microsoft Access as our database. So the basic things you need for a database to do, all right, basic requirements of a database management system, DBMS. You got to be able to create tables and relationships. You have to be able to maintain data in the tables. What we mean by that is you got to be able to add data, update data, and delete data as needed. You need to be able to query the data. So this part is the create this top part here is obviously creating the structures and loading them. Querying is the querying data is the thing, basically being able to get data out, asking questions of the database, be able to get information back. All right. And then once you gather that information, the ability to report on that data as well. And then finally control access to the data. So there's one of the key functions of this stuff is you want to, especially this is a shared, this data can be shared across multiple users. So the idea is that not everybody should have the right to read everything in all the tables. So there's a couple requirements. So one of the things that COD came up with is what he calls a couple rules that define what a relational database is. All right. So one of the couple things. So first thing is a field has to have a distinct name. Right? So every field has to be unique. You can't have duplicate fields in the same table. All right. All values in that field, everything in that field represents the same attribute. Okay, so what will happen is you'll have like order date. We'll go use our example of order date again. Order date is you have a field order date. All right, so it will have a unique name order date. There cannot be two order dates in the same table. All values of order date represent the order date. All right, so you can't intersprinkle zip codes in the middle of the order dates. Right? And this is actually this right here, or the distinctiveness, the uniqueness of each record. All right. One of COD's rules is that every row has to have a unique, have unique. And the way you do this is you establish what we call a primary key. All right. Uh, this is the technical term for this is what we call entity integrity. Every row in a table is unique. All right. So this idea is you have one field that is different than any other field. You can do this in a whole number of ways. Obviously, one way is if there is a field that is unique, you can assign that to be the primary key. You can assign a bunch of fields to be the primary key. It doesn't have to be a single field. A primary key can be made up of 2 or 3 or 4 different fields, so long as it makes it unique. Or you can just assign a number, or just assign an incremental number to that. A lot of times with we'll call that term a surrogate key, but that's basically a lot of times you just simply assign a number to it, and that becomes your the next number that's out there, and that's what you use as your primary key. The order of columns in a database is immaterial, as well as the order of rows. So now we'll talk about this when we do querying, that you can add order to this. You can restructure it yourself, but the way the order of the columns are stored and the order of the rows is immaterial. It's actually pretty flexible. So you just you don't spend a lot of effort loading data in to organize it. It's out there, and then you can organize it as you bring it back, as you query it and bring it back. Create a table. Basically you define the properties. You assign a name and you define the properties. Every field has a data type. All right. So once we talk about this concept of rules. So some of the rules associated with a field, you assign a data type, you assign a size of the field, all right, and some type of description of it. All right. You select a primary key. All right. Which field will be the primary key? Once again, it's in Access. The primary key actually you can actually operate without a key, without a primary key. It's not immediately important. However, COD's rules, and if you look at the relational rules, this is one of his primary. Rules. Right. Must uniquely identify each record and can consist of one or more field. All right. And if you do more than one, we call what we call a composite key. Mm. And these are the different types of data, the fields that can be assigned to a data type. So, these are um, basically the characteristics of what you're going to put in there. So, say, for example, if you have a numeric field or a field that's going to be holding information or data related to say like a, with cash, you could use currency. All right. If you have just simply a text, if you just look, just a field of letters and alphanumeric characters, you can use short text. If you are put a date, you can use date time. Right. So all of these are different. These are the different um, field types of which can be assigned, and what you need to do is every field you define in the database has to be assigned some sort of data type, and that is the rule that establishes what you can put, what type of data you can load into that. Okay, and that is it for our first part here.